Okay, let's have a look at this one then. Here's the question. We're given this formula for the rate of decay at a certain mass. When T is 0, it initially has a mass of m0. K is this value. It says calculate the rate of mass that it decays at initially when m0 is 40. So let's get the MDT and then let's worry about what that means, shall we, first? Because we're talking about rates, so we're going to need to differentiate. Because whenever we talk about rates, then if we have a value of a function, then the rate of mass will definitely involve the derivative. So here, e to the something t. Now, we've got to be careful here because we know e to the ax, but if that were a t variable, then differentiating with respect to t would be a e to the at, yeah? So the process is the same, just a variable, instead of it being an x, is a t. So dm dt then is equal to, the minus k comes down, doesn't it? m0 e to the minus k t, that's the derivative then. We did exactly the same process except that we were using the symbol t instead of x. So that's just differentiating this function. Okay, initially t equals 0, so it'll be minus k times m0 times 1, because t is 0, e to the 0, which this will be, is 1. And then we know k, which is 0.0308 minus times m0, and we're told m0 is 40. So let's type that in the calculator. 40 times 0.0308. 1.232 with a minus. Now that's the MDT, that's the rate of mass increasing. So it's because m is here, so dmdt is viewed as a positive rate of increase. We're asked to find the rate of decay. Because this is negative, we can just drop the negative, so it's 1.232. So this would, the MDT is the rate of mass increasing, but the question says what is the rate of mass decaying? So the rate of mass increasing is negative, is the same as saying the rate of mass decreasing is positive. And that's what they actually asked for, so we drop the negative. And then when t is 20, okay, let's put that in then. So dm dt, same thing again, is equal to minus 0.0308 times 40 times e to the minus 0.0308 times the time, which is 20. So let's type that in the calculator then. So I'll leave that negative there, 0.0308 times 40 times e to the minus 0.0308 times 40, 0.359 minus 0.359 is what I got at the moment. Now the only thing was, the answer was when t was 20. I seem to have written 40 and confused it with the mass. Because that's the mass, but this was the time. So time needs to be 20 here, doesn't it? So I'll need to change that in my calculator. Let's just do that then. See what we get. So change that last 40 I wrote to a 20. And that's better. That's the input at t equals 20. 0.665. With a minus. So the rate of decay then, drop the minus, just as we mentioned before, 0.665.